Hi friends, today we are going to say Introduction to Trigonometry. Trigonometry. Trigonometry is composed of three words, tri, gon, metron. Tri means three, gon sides and metron means measure. It is a Greek word. So trigonometry is the study of a relationship between the sides and angles of a triangle. Now let's consider a right angle triangle which is right angled at B. Okay, let's take angle A. If we take angle A, now we are going to name the sides of the triangle. We know in a right angle triangle, the side which is of the greatest length is the hypotenuse. Okay, if we take angle A, the side which is opposite to angle A is the opposite side. And the side which is along angle A is said to be the adjacent side. Okay, if suppose we are considering angle C. If it is for angle C, the side which is opposite to angle C is the opposite side and BC will be the adjacent side, and as we know, this is the hypotenuse. Now we are going to see the trigonometric ratios based on the angles. Let's consider a right angle triangle, just right angle at B. First, it is sine of angle A, which we write it as sine A. Sine A is opposite by hypotenuse. So for angle A, we know the side which is opposite to angle A is BC. So this is the opposite. So we get BC by AC. Next comes cosine of angle A, which in short we write as cos A. Cos A is adjacent by hypotenuse. So the adjacent side is AB by hypotenuse is AC. Then comes tan. Tangent of angle A, we write it as tan A. Tan A is opposite by adjacent. So here the opposite side is BC. It is BC by AB. Okay. See here, the three basic trigonometric ratios are sine, cos and tan. And these ratios can be easily remembered by using a simple phrase. Old hunter and his old axe. You can just remember this phrase, and with the first letter you can get the trigonometric ratio values. See here, this is opposite by hypotenuse, adjacent by hypotenuse, opposite by adjacent. See, just remember the phrase and the first letter gives you the way by which you can get the ratio values easily. So these three, this is sine, cos and tan, you have to take in order. So when you know the values for the sine, cos and tan, then you can easily get the values for the remaining three, that is the cosecant, secant and cotangent. Okay, see here, if you refer to the table, sine A I have written as opposite by hypotenuse, whereas cosecant A is hypotenuse by opposite. That is, it is the reciprocal relation of sine. We can say the cosecant is the reciprocal relation of sine. Therefore, we can write this as, we can write cosecant as AC by BC because the cosecant is reciprocal of sine. Similarly, if you see the table, cos A is adjacent by hypotenuse, whereas secant A is hypotenuse by adjacent. This is the reciprocal, therefore the values will be AC by AB since it is the reciprocal of cos. And cot. So cot is the reciprocal of tan. Tan is opposite by adjacent, whereas cot is adjacent by opposite. Therefore, we can write this as AB by BC. This is 1 by tan A. Sine, cos and tan are the basic trigonometric ratios, and this tan can be expressed in the form of sine and cos. See here, tan A can also be written as sine A by cos A. We know the value of sine A, it is BC by AC by, and cos is AB by AC. Here, by just getting the values, it is division. I am just writing it in the reverse way, that is reciprocal we get the value of tan A is BC by AB, isn't it? So here we just tan A is BC by AB. Therefore, this tan can also be expressed in terms of sine and cos. That is, tan A is equal to sine A by cos A. And similarly, this cot A can be written as cos A by sine A. Now, let's see some relationship among the trigonometric ratios. The first one is the reciprocal relation. We have just seen it, isn't it? So, sine theta is 1 by cosecant theta and cosecant theta is 1 by sine theta. Similarly, cos theta is equal to 1 by secant theta and secant theta is equal to 1 by cos theta. Tan theta is equal to 1 by cot theta and cot theta is equal to 1 by tan theta. Okay, I'm just summing it up. See here. It can be right. See, once you know one relation, that is, you can just, the other relation is the reciprocal of this. Sine is for cosecant and cos is for secant and tan is for cot. So this is the way you can just, you can apply the reciprocal relation. Next one is the trigonometric ratios of complementary angles. See here, the complementary is what? Two angles are said to be complementary when they sum up to 90 degree. Okay, now we are going to apply this here. Sine is complement to cos. See here, sine 90 minus theta is cos theta and cos 90 minus theta is sine theta. Tan 90 minus theta is equal to cot theta and cot 90 minus theta is equal to tan theta. Secant 90 minus theta is equal to cosecant theta. Cosecant 90 minus theta is equal to secant theta. I'm just giving you just a hint to remember this complementary pair. That is, sine and cos are the complementary pair. You know, sine and the full form of cos is cosine. Isn't it? See here, sine and cosine, they are complementary. It is sine, cosine. Similarly, this is tangent. And here this is cotangent, isn't it? The full form of cot is cotangent. Here, they form the complementary pair. Tangent, cotangent, they form the complementary pair. That is tan and cot. Similarly, secant, cosecant. So, secant, cosecant. So, here, the secant and cosecant, they form the complementary pair. This is how you can remember that easily. Then comes the trigonometric identities. There are three basic identities. There are three important identities which you have to memorize. Sin square theta is plus cos square theta is equal to 1. Secant square theta is equal to 1 plus tan square theta. Cosecant square theta is equal to 1 plus cot square theta. See, once we know this, it can be written in other forms as required. See here. I'm just giving an example. See here, sin square theta plus cos square theta is equal to 1. We can write sin square theta as 1 minus cos square theta and cos square theta is equal to 1 minus sin square theta. Similarly, we can just apply for other relations too.